Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
In this session, we will continue discussing the various factors affecting evaporation from a water body. We have seen this couple of factors such as radiation, the surface temperature around the water body, the wind around the water body, the atmospheric pressure around the region of the water body. So, and along with humidity. So it's obvious that if these three parameters, if they increase, the rate of evaporation will increase. Whereas if you talk about atmospheric pressure and the humidity in the atmosphere, it's an inverse relation, meaning that if the atmospheric pressure increases, the evaporation rate decreases. Similarly, if the humidity in the atmosphere, if it increases, the rate of evaporation decreases, conversely. So in addition to this, you can see the next one, that is, if you take the size of the water body, size means, now if you say the exposed surface area, right? If the exposed surface area, if this is more, the area increases, then the rate of evaporation will decrease accordingly. If the size of the water body increases, right? If the surface area of the lake increases, that means the exposed surface increases. The rate of evaporation will proportionately increase. It's a direct relation between the exposed surface area and the rate of evaporation. If you talk about the quality of water, quality of what? Quality in terms of pollution. For example, if we compare between fresh water from the river and the polluted seawater, polluted means the water in the sea contains lot of chemical salts, especially the sodium chloride. So if salts are present in water, it is polluted, then the rate of evaporation will decrease, slightly decrease compared to that of fresh water. That means if the quality of water increases, the rate of evaporation will also increase. It is reported in the literature that the evaporation from river water, evaporation from river which contains the fresh water, is 2 to 3% higher than evaporation from sea, or we can say evaporation of seawater. And this is under, we have to also mention this, for this to be true, under identical conditions. Identical means the rest of the factors being same or constant. Okay, only if you talk about the quality, then you can say that as the quality increases, the rate of evaporation also increases. So, and in comparison, when we say storage of water or development of water resources, basically we are talking about development of freshwater sources. Fresh water, that is rivers, streams, lakes, and ponds, where we get a lot of quantities of fresh water. So we do not, waters in the sea or the oceans does not mean much to us because we cannot utilize them directly, and hence they are of no relevance. But when it comes to evaporation, water evaporates, and such waters also cause precipitation in the form of fresh water. Okay, so that's something about the factors affecting evaporation, and then we shall take up measurement of evaporation. I shall write here measurement and estimation of evaporation. So there are various means by which we can measure the depth of evaporation. It can be from what you call the pan measurement, evaporation, various methods include number one, pan measurement, also called as, the setup or the instrument is called as evaporation meter. There can be empirical methods of measurement, and we also have analytical methods of measurement of the term called evaporation. So we have empirical equations to assess the loss of water resources by way of evaporation, in addition to analytical formulae which are relevant in the estimation of evaporation. So let us take it one by one under measurement. So the first thing that we will take up is the pan measurement. Okay, evaporation with the help of pan. First one is pan measurement. Pan means it's a vessel, a metallic vessel, okay, which is nothing but also the evaporimeter. So in this, basically what we do is we take a standard standard pan. It's nothing but a metallic pan made out of metal, maybe a galvanized iron sheet or a copper sheet, and this is developed into a pan. This pan is installed. It is kept just beside the water body. If this is the water body, okay, then if we have to measure the evaporation from this, the pan is installed here. Of course, there is a small table or a stool arrangement on which the pan is kept. There is a wooden stool with a slight gap to allow the movement of air, and these waters are filled. The waters from the same water body or the lake from which we have to find out are taken and they are filled into this, right? That's the pan. This is a simple arrangement of an instrument called as pan. Nothing much complicated about it. Now what we do is we wait for a day or two, whatever, a certain specified duration. We know that evaporation will occur. The water will eventually evaporate, due to which the level of water that was a predetermined level of water in the pan drops down, and this drop in the level of water is then this represents the depth of a loss of evaporation. Okay, then how do we measure this? Of course, we employ standard pans. The first one is the class A standard evaporation pan. Right? This is basically used by the United States, the Weather Bureau, this uses or this employs the this evaporation pan to make a measurement in that country. When it comes to India, when it comes to the Indian standards, the Bureau of Indian Standard has actually recommended a modified class A pan, a slight modification. So that is called as the modified class A pan, that is evaporation pan. This is employed by the Indian standard pan. The Indian government, the Indian Weather Bureau uses this modified class A pan to measure evaporation. Now this one interesting or one important aspect of engineering is any procedure, any experimentation or a procedure or a methodology or evaluation in any aspect of civil engineering is basically governed by Indian standard codes, Indian standard code books, which are provided by the Bureau of Indian Standards, have to be referred to whenever we do certain process or whenever we carry out determination of properties or values or any such things. We have to rely upon the methodology prescribed in the Indian standard code books, of course, which are provided by the Bureau of Indian Standards. One such code book for the determination of evaporation is IS. IS stands for the Indian standard. This is 6939. Indian standard 6939. Now this code actually gives the specifications for the conduct of measurement of evaporation from water bodies. So whatever has been prescribed, we shall be following rigidly in the measurement of evaporation in this book. This is out of academic interest. This is Basically the title is Method of Determination of Evaporation from Reservoirs, that is IS 6939. Now the Indian standard, according to this IS 5973, you can refer to this IS 5973, that is published in 1970, or probably it is revised now, but anyway, this is the number, this is the code which governs the specifications for the pan that is used in the context of India for the determination of evaporation. Now according to this code, we have a metallic pan. The metallic pan that is used as class AA, it consists of a GI sheet that is molded into the form of a pan. But the metal that is used to prepare the Indian standard pan, that is a modified class A pan. Now this is the modification. The metal that is used in the class A pan is the GI sheet, whereas in Indian context, in the modified class A pan, it is a copper sheet that is used to make the pan. Same thing, the installation is like this. Now we have a pan. Pan means a vessel having a very shallow depth. The sides are not very great when compared to the size of it. Size means here it's a circular pan, and hence the diameter. Okay, let me do this in detail. So this is a pan whose depth is prescribed as 255 millimeters, and the diameter of this is 1.22 meters or 1220 millimeters. Now this is the specifications of the pan that is employed in the Indian conditions. What we do is, this pan, as I have earlier mentioned, is to be installed very near in the vicinity of the reservoir or the lake. So it is not directly kept on ground, because it can borrow the temperature from the ground, and hence the evaporation calculations might be different from what actually they are. So it is mounted on a wooden platform, because wood is a bad conductor. So we have a wooden platform. I guess I shouldn't do this so much. Okay, onto the ground. Now this is the ground, and we have a wooden platform. So this is the wooden platform on which it is mounted. This is, I will write down, the wooden stool or the platform on which the pan is kept. Now this pan is made out of copper sheet here, that is molded into the form of a pan. In this, what is done is, the waters are filled from the reservoir or the lake from which the evaporation has to measure, and the depth of water inside the pan is, or the standard level up to which the waters need to be filled in the pan are this depth is 200 millimeters. So what is essential is, this become relevant. The diameter is 1.22 meters or 1220 millimeters, and the depth of water inside the pan, actual depth is 255, but the waters need to be filled only up to this. Now there is a mark here, right? This is the specified depth up to which you have to fill the water, and that happens to be 200 millimeters. The person will come from the weather bureau, he will fill water in this pan and he will wait for a day, or maybe if it is a slow process, he will wait for a week or a month also. Now, how to measure this, the evaporation depth? This is a metallic pan and contains no markings on that. Unlike a glass jar or a glass vessel, we have marking, and because it is transparent, we can easily compare the depth of the liquid that is inside with the marking on the outside of the glass vessel. But this is metallic, and hence depth markings are not there. It is a plain, plain metallic vessel and contains a small mark all around at a depth of 200 millimeters, indicating that up to that depth you must pour the water and wait for evaporation to occur. Now, after some time, maybe this level will come down. The level will come down, isn't it? I'll indicate it here in the vessel. This is only diagrammatic. Don't go with the scaling of this diagram. It is only indicative of, just for you to understand very easily. I have drawn like this, deeper one. This is the specified depth. This is a specified depth, and that happens to be 200 millimeters as prescribed in the code. Now, what happens is, after, let us say, after a day or after a week, the water level will evaporate, and the water level will drop from 1 to 2. Now this is a drop due to evaporation. Agree? The water level will come down. So this depth basically is nothing but the depth of evaporation. That is E. Okay? This is the depth of evaporation here. Now we have to find out this depth corresponding to the shaded portion that I have marked here. Now how do you measure this? Because there is no measurement, no marking. So what we do is, this pan which has come down to 2, earlier it was here, the water were filled up to the level 1. This is the 1 is the specified depth. Okay, this level 1 corresponds to the specified depth, and the water levels will drop down to 2 because of evaporation. Now we have to, this is the specified mark. Now this becomes the depth of evaporation. Now how do I get this? Okay, to determine this depth, we have to do some calculations. We have to perform some procedure. What we do is, let's say the next day or the next week, the person comes, the responsible person will come, and then he'll notice a drop in the water level. If there is a drop in the water level with respect to the specified height, he will come, take the waters from the reservoir and pour in this, take the waters from the reservoir and he will pour into this vessel until the water levels will rise. Okay, the water will rise up to the specified height. So we have to pour water until the water level rises and reaches number 1. So this becomes, this shaded portion is nothing but the volume of water added in. Because the level has gone down, then we are adding water, so the water level have risen back to level 1. That is the specified level or the specified depth. Now, when you know how much water you have poured, so we know the volume of water that is poured because we measured it. Okay, then the depth of evaporation, okay, let's say in millimeters, that is E, is then calculated as the volume of water added divided by the area of pan. This will be in millimeter cube and this will be in square millimeters here. So very similar to the non-recording type of rain gauge, wherein we don't get the direct measurement. We have to measure the volume of water in the rain gauge, that is caught, the bottle reading, and then we calculate the depth of precipitation. In the same way, we are calculating the evaporation depth also. So knowing the volume of water added, we can divide this volume by the area of pan. The area of pan, because it is circular pan, we know the diameter, and with the help of this diameter we can calculate area. This will give us the depth of evaporation. So one caution that we need to exercise here is, because there is a manual involvement, somebody is working on this, so we have to be very careful in pouring the waters and measuring, because a correct measurement will lead to a correct data, and this data helps us for many years to come. Hence the work has to be done with lot of integrity. I would now want you to copy this before I give you something else on this. I mentioned here two IS codes. The first IS code says the method of determination of evaporation from reservoirs, and this code IS 5973 is a code which gives the specifications for the Indian standard pan. Now this is modified, or the Indian standard evaporation pan. Kindly copy this before I tell you something more about this. You can also mention here it's a wooden platform, and the depth of the platform is about 100 millimeters above the ground level. You can write something about this pan. Couple of points, please write down. The first one is the modified class A pan. Please write down. The modified class A pan or the Indian standard evaporation pan or the Indian standard evaporation pan is made from a copper sheet of 0.9 millimeters thickness, no, very thin, 0.9 millimeter thickness, such that it has a diameter of 1220 millimeters and a depth of 255 millimeters and a depth of 255 millimeters. Next point. The specified depth or level up to which the waters are to be initially filled. The specified depth or level up to which the waters are initially to be filled is 200 millimeters. Okay. Next, the pan is mounted. The pan is mounted on a wooden stool. On a wooden stool, 100 millimeters above ground. 100 millimeters above ground to prevent heat exchange, and also to allow free circulation of air around the pan. Okay. Now the measurement is, of course, I have mentioned here, but I would like to add something here. See, the discussion here was that the water levels drop after evaporation, but this drop in the level of water doesn't happen overnight. It takes a long time because the evaporation rate is very, very slow compared to precipitation. So it takes a long time. So to notice the difference in the dropping level, we may need to wait for many more days. So let us say if we come back after a month, we'll obviously see a drop in the water level. But what if rain comes? What if rainfall occurs during this period of the month? Because it is open to sky, so it will act as a non-recording type rain gauge. It will act as a container to receive rainfall. So if rainfall occurs in this. So there will be two things, addition of water due to rainfall and reduction in water due to evaporation. So there will be two features, involved here. So in that case, if you simply measure the drop in the depth, you will report only the waters that have lost due to evaporation. But what about waters that have been added due to precipitation? So the water levels may not come to 2. The water levels may be in between here, maybe, who knows. It will be here, or it might also exceed 1. Because the rainfall, if it is too heavy, the waters might also cross 1 because it is collecting the rainwater. So in that case, necessary corrections need to be made. These calculations, I would probably explain them comprehensively in a numericals. This is the best way to understand the correct way of measurement. I have only told you the situation, the condition. Same thing we will try to elaborate in the numerical problem. One of the features, now you can also write there that the one more point you can add here. The pan is completely fitted at the top. The pan is completely fitted at the top by a metallic hexagonal wire mesh. By metallic hexagonal wire mesh. Now, in addition to this, there is also, we need to cover it up at the top. At the top, we fix a hexagonal. You can also mention this in your notes, in the diagram. Hexagonal wire mesh is fitted at the top. Okay. Why this wire mesh is kept is because it's a large pan, more than a meter or so. The effect of temperature, the effect of wind, the effect of radiation might be different at different points in the pan, even though it's a smaller one. 1.22 meters is not very, very large, but within that dimensions, there might be variation of effects by radiation, of temperature, of pressure, wind, everything. So in order to make it consistent throughout the pan, the effect of all these parameters, the wire mesh is fitted. Of course, it doesn't stop anything, but then this wire mesh will also prevent, in a way, it acts as a protection from maybe the birds or the humans or the animals, maybe wild, domesticated, because it is kept in the open, so it is susceptible to all such vagaries of life, such. So in order to protect this, protect in the sense, protect the quantity of water in the pan, it is fitted with a wire mesh at the top. It's not only physical, but also to prevent anybody from using those waters. Right. Another aspect is the pan. The pan is tinned inside. Tinned inside. Galvanization, something like that. It is tinned inside and is painted white outside and is painted white outside. Right? These are the specifications that to be followed, and accordingly we need to, what do you call, do the measurements. This is something regarding the Indian standard PAN. But one essential effect, or rather difference in measurement, we have to note here. As I have mentioned, this pan is to be kept very near to the water body. Maybe the water body is here, by the side of it or on the bank of it, we have to install this evaporation pan. It is observed actually that the evaporation from this metallic pan is different from the actual evaporation. That means the pan evaporation, the evaporation that takes place from the pan, is distinctly different from the actual evaporation that takes from the water body. There is a difference, and this difference is about 14%. Generally, in Indian context, it is reported as about 14% or so. That means the evaporation measured in the pan and that which actually happens in the lake are not equal. They are different. And these two different values are correlated with the help of PAN coefficient. So let us try now to define the PAN coefficient. Let us write down the coefficient of PAN, or PAN coefficient. This is defined by the ratio of lake evaporation by PAN evaporation. PAN coefficient Cp. Because the evaporation from the lake, which is actual, is different from that occurring from the pan. So we have a difference, and that difference is reflected, or rather represented, by the PAN coefficient. For the US Bureau, the Class A PAN, if Class A PAN is used, that is the US Weather Bureau, Cp is taken as 0.70. That means 70% of the pan evaporation is the actual evaporation. 0.7 means, if you substitute 0.7, lake evaporation would be 0.7 times pan evaporation. That means 70% of pan evaporation is the lake evaporation, which is actual. Okay. Similarly, for the Indian standard, the PAN coefficient is recommended as 0.80. 0.80 means 80% of the PAN evaporation is actual evaporation from the water body. So they are not equal, and they have to be correlated with the help of these two. Kindly note this before I give you the value of evaporation. Okay, you can write down, put a star and line as a special note, saying that, you see, earlier in precipitation we have said that the annual rainfall in India is 119.4 centimeters as of today, right? And the annual rainfall depth, annual runoff depth is 55 centimeters in India. In the same lines, what is the depth of the annual evaporation that occurs in India? So this I'll dictate, you please write down. Put a star and write down. Under Indian conditions, the evaporation from a water body, under Indian conditions, the evaporation from a water body is about 160 centimeters, 160 centimeters in a year, 160 centimeters in a year, with enhanced values in arid region. Enhanced values in arid regions. Arid means very much dry. Okay. So that is what is there. This is the standard value that is to be remembered, that the annual evaporation for India happens to be about 160 centimeters or more in some places like Gujarat. Okay, there's a desert portion in the north of Gujarat bordering Pakistan is relatively dry. Rajasthan bordering Pakistan is relatively very dry. You all know this, So these are the places which are very dry. In such cases, the evaporation losses are very, very high, right? Such regions are called as arid regions. But generally speaking, the most of the parts of India comes under semi-arid regions, especially the central and the Deccan Plateau comes under semi-arid region. That's why India in the universe, in the global concept, right? From the global perspective, India, of course, it is called as a tropical country, but technically it is referred to as a semi-arid tropic region. Semi-arid means not so dry, Of course, we have a reasonable amount of rainfall coming, and we have reasonable amount of water resources also available in India, right? But still problems are, we are facing problems with shortage for various, activities because of lack of awareness, because of lack of civic sense, because of lack of understanding. That's the reason why a civil engineer has a very big responsibility on his shoulders to inculcate. First, he has to imbibe the sense of responsibility towards his water resources. The civil engineer has to do, because he is the first one in the list to talk about, to feel about the water resources, and then it has to be translated into awareness. He has a responsibility, an additional responsibility to bring forward to the society about the importance of water resources. Are you following? If we can't conserve, if we can't protect the water, quantity of water, even though we may have a reasonable amount of rainfall, but if you can't convert it into storage, then it is going to affect us very badly, isn't it? To mention here, the places like Cherrapunji, Mawsynram or the places in Meghalaya which I was mentioning where the rainfall is highest in the world, they face almost 9 months of drought, water shortage. Is it not ironical that a place which receives maximum rainfall in the world faces water shortage? And that is where we have to enlighten ourselves. That is the place where the conservation concept comes. We need to conserve water somehow, and that is where hydrology subject plays a big role in making us understand, right? Anyway, so now a small point you can mention here, that is about the reservoir, reservoir volume, reservoir volume, evaporation rate, reservoir volume, evaporation rate. That means the volume of, you can write down under this, the volume, you also write down the volume of water from a reservoir lost due to evaporation can be found as this volume directly is A into EP into C. Of course, it's only a simple form. Given the depth of PAN evaporation, we can calculate in terms of quantity, in terms of liters of water. Okay, how much of liters of water we have lost due to evaporation can be found out from this formula, where of course the V is the volume of water that is lost due to evaporation, and A, you can write down, I'll dictate. A is the average reservoir area, that means the exposed surface area of the reservoir. EP is PAN evaporation, you can mention this quickly, and CP is PAN coefficient. Okay. So knowing these three, we can find the volume of water that is lost due to evaporation. So in this session, we will stop here, and from the next session, we shall continue talking about the evaporation, or rather the measurement of evaporation by different methods. We have discussed the PAN, and now we will discuss the